is it right that the model of innovation, the model of superior innovation, continue to be that of the United States, or Germany, from this point of view, can be considered from not any point of view, but many point of view, superior to the American innovation system model? There are a lot of analyses about this comparison, one of interest in the Harvard Business Review, and these analyses show how, even if I was discussing with Raditsch, Mr. Raditsch, I was not, don't agree very much about my pro-German support endorsement. But these analyses show some features that are interesting to analyze. There are important and crucial sector innovation in which Germany is considered without any doubt superior to the United States, are sustainable energy system, laser, molecular biotech, experimental software engineering. And these are crucial innovation, crucial technology for manufacturing industry. What is the characteristic of a German innovation system? That is ability to adapt invention to industry, spreading throughout the business sector, and also recombining elements of all the stagnant sector in new vibrant one. What is important is the improvements in manufacturing prowess, and the data show this superiority compared to United States. As a percentage of labor market, 22% is from manufacturing industry. In Germany, only 11% in US. And share GDP, 21% in Germany and only 13% in US. Then from the point of view of manufacturing industry, the superiority of Germany is very strong. The characteristic, as I told, was innovation that is not only focused in startup or incumbent giants in ICT as the US, but are more widespread in all the business sector. The network of public institutions, and here we are inside the model of Triple Helix, that support the innovation, and the first of them, Fraunhofer, is very is known by everyone, and United States want to establish 7 new office of Fraunhofer in the US because they find the model very interesting. But training of workforce to exploit the most radical innovation to improve products and services. This is also important characteristic. And the fourth is the characteristic that more or less is linked to our debate, the education system. The education system is an education system that is more close to the business sector, to the labor market. And I think this is one of the real superiority of Germany. And this is an old path dependence in education policy that go until the 19th century. You know that discussing about the model, there is the Napoleonic state centralized model of education. There is a more Anglo-Saxon bottom-up model of education, more linked to private sector. There is the Humboldtian, from Humboldt model of German education system that has the characteristic to, as a mix between the first and the second, but has the ability to be more close to the labor market. And also to the phenomenon of technology transfer. If we think of the importance of this model during the organic chemistry revolution in 19th century, that it was the first important phenomenon of technology transfer in the world. And this is because of the peculiarity of this education system that is coherent from this point of view to the national innovation system in Germany. That is neither a grassroots model as in the US, particularly California, nor a catching up model as in emerging countries. It is a mix between top-down, bottom-up, demand pull, technology push, but it works, particularly for what we think is important to maintain a strength of an industrial system in manufacturing. And I conclude, I think the best example, explanation of this strength of the innovation system of Germany is this town, this wonderful town. And is the heart of the European culture, is also the center of science and technology in Europe, with many Nobel Prizes, with a lot of institutions that are able to cooperate with the business sector. Thank you very much, and now we start with a change of the program. Dr. Martin Raditsch should go away in half an hour, more or less, and he will begin with his speech, his comment, the role of industrial university cooperation for the German innovation system. Martin Raditsch was appointed Managing Director of Innovation Lab GmbH, following his graduation in molecular biology at Ruprecht Karls University, Heidelberg. Martin Raditsch worked in the life science sector at the BASF SE, where he held several management positions. In 2001, he joined EMBA, Enterprise Management Technology Transfer, and his responsibility included business development and the commercialization of IP. He was appointed Deputy Managing Director in 2004. Please.
Yeah, thank you very much for a nice introduction, and sorry for the confusion, but I have to leave around 2-ish. So I would like to give you a short introduction of what I'm doing and how we... next one, please. Yeah, right. And then present mode. Yeah, what we are doing in a so-called joint development platform. I'm heading a public partnership right now, where we try to translate invention into innovation. And the invention as such, well, we're doing in Germany great, I guess. Many universities, many Max Planck institutions, which are really outstanding, and Leibniz and whatever. Well, I'd like to just talk about all of those. They're very inventive. And then the gap comes towards the invention. So who's responsible for invention? Well, in Germany, the companies are, of course. And here, a lot of small and mid-sized companies are responsible for dragging along the inventions. Because without inventions, no products, without no products, no GDP, and so on and so forth. So, how you can speed this process up? Well, many people spend a thought on that, and then we came up for a specific field, the printed electronics, pretty new, how we can do that in Germany. So, I guess you don't have a clue what printed electronics are about. So electronics, you know, if you smash your mobile phone somewhere at the table and it opens, then you see electronics. So you see bits and pieces here, over there. And if you print them on a layer, then you have printed electronics without a single resistor, without a single diode, transistor, capacitor. So right now we're in the status of transforming such kind of invention into an innovation. Innovations look like that. So OLED, you're aware because, well, maybe a third has a Samsung mobile phone, another third an Apple, and then we have another third. So the Samsungs most likely have the OLED technology already inside, but on a very old-fashioned traditional way implemented. Now we're talking about OLED printing. OPV, the same story. So photovoltaics printed on every kind of surface, building, especially interesting for emerging countries where we have enough sun. Then transistors with low consumption of rare earth, for example, because they're based on organic chemistry rather than on inorganic chemistry, and so on and so forth. So this is my daily business, creating such kind of inventions into innovation. One of these innovative examples you can see, well, this was a prototype from BASF and Smart. BASF is one of our partners there, and fully packed with just inventive stuff. This car is just an invention, not an innovation, because the car will never hit the market as it is. It's just built from research materials. But part of the cars, you will see in your car in about 2 up to 5 years. So they are entering into the market then. Bless you. So we are going for high throughput, low energy, additive and digital. These are our steps. And how would we do that? Well, we're using old-fashioned technology of printing. Take a little bit of university, take a little bit of industry, shake them, and hope that we come up with innovative ideas, which obviously is working. Who's we? Well, we, from the industrial side, it's a consortium which is not really fitting very well together on the first glimpse. It's BASF and Merck, the big chemical companies, then Heidelberg printing press, SAP, a data company, and then the University of Heidelberg and KIT, that's the main shareholders. But the idea behind is very easy. We would like to build the value chain. So we have the universities, which are very, very, very the beginning of the value chain. And so they come up with the invention. Now we'd like to pick up the invention and work with the companies, so with the chemical companies that will get the materials, the mechanical companies, Heidelberg printing press, that will get the machines, and SAP that will get the end consumer, because if we talk about electronics, we talk about data. Nothing more than that. The end product of electronics are data. And this we have to work with. And so SAP is part of it. And, well, one could say, okay, fine. Just take this and you do such kind of collaboration. You meet every 4 months or every 3 months. You do a little bit of Skyping and you burn a lot of money, public money. In this case, we did it differently. So we built a joint research institution in Heidelberg. We're just located next to the railway station here, and put all the scientists from all the companies and all the universities you see at the bottom together just to work jointly on projects. So the inventors brought their invention and the innovators worked on the inventions with the companies ending up with a product. And so we had the possibility of building up the whole value chain from R&D down to the market. Of course, there are usually gaps. So the orange part is pretty much the part of the universities, the research institutions. And then it got really tough to get it somewhere into the market, because the conception of the devices is a little gap. Then the production system is still a gap, and the sales applications, of course, the big companies take over. I would like to support the SMEs, so every SME who is willing to can join our joint lab as well. It's pretty much like the golf system. So either you can buy a share of your golf course. Golf club is a German expression, of the golf course, or you can get an annual fee, or you can just get a green fee ticket, depending what you want to do at our research site. So the smaller companies can buy in and work on their innovation part, and the bigger companies, of course, are quite happy to say that. Well, they bought huge chunks of the company, so there the huge money comes from where we're working with. Yeah, and so we have some kind of innovative spinning wheel based on our technology, the printing technology, where we start from the very beginning of the process with simulation. That's mainly university-driven, down to device physics and prototyping, which is industry-driven. Putting all these guys together, industry as well as university, gives us about 60-fold more speed than an average collaboration industry has with academia. Because the people are sitting together the whole time, they can exchange information immediately with each other. And I think this is also necessary to keep track and to be speedy. Why? Because, well, I travel Asia a lot now, and there is so much pressure from the market, but also now from the research, that we in the Western world have to keep pace. And keep pace, you can't just do like you did for the last 10 years, 20 years, 40 years. We have to invent new models. The question is whether Europe has to have its own model. Because if you look at Silicon Valley, there is a decent model going on, which I would say. And we now started here in Heidelberg 5 years ago a new model where we would like to speed up the transfer of knowledge and technology. It's not only about technology, it's also about knowledge, from the first spark of an idea to the ready-made product. Yeah, and a few startups, of course, we also lifted up. Here we see Ms. Vanka, our minister. She's responsible for fueling us to a certain extent as well. So, thank you for your patience.